Good day, everyone. So, for our week 3 discussion on general mathematics, we will be talking about annuities. When we say annuities, it refers to sequence of equal payments made at equal periods. So, whenever you're experiencing making payments, no, equal payments, no, exactly, to be exact, no, equal payments at specific periods of time, that's called annuities. Now, payments may be done annually, semi-annually, or etc. So, we will go deeper into that. There are different types of annuities. So, according to duration, or how long the annuity will be. So we have annuity certain. With annuity certain, it's very clear that um, the annuity has a specific beginning and end. No? So when will you start paying the annuity and when will you end paying the annuity? While on the other hand, we have contingent annuity wherein the duration or the length of, of annuity is not certain. It only means that the payments will extend, will begin, or will end on a specific event, no, which is indefinite or indeterminate. One example of contingent annuity could be pension. No, kasi pension, you know when to start receiving that. That will probably be when you retired, no. Pero mag-e-end siya kapag ikaw ay, when you passed away. So that's very indeterminate. We don't know when will that be. It's contingent annuity. According to the time of payment, no, when will you make the payment, we have ordinary annuity and annuity due. With ordinary annuity, so the payment will be made at the end of each payment interval. For example, if it's monthly, so at the end of the month. While annuity due, at the beginning of each payment interval. So we're going to make payment at the beginning of the month, at the beginning of the quarter, at the beginning of the year. So that's ordinary annuity and annuity too. So according to payment interval and interest period, so we have simple annuity and general annuity. So if we are if we are making payments and we are having interest on those payments, both on the same period of time, that's called simple annuity. So we just have to be clear onto that. So the payment intervals, let's say monthly, you're going to make a payment every month, and then the interest period will also be monthly. That's called simple annuity. On the other hand, if the payment interval is different from the interest period, let's say you're going to make payments every quarter, that's your payment interval, and then your money will earn interest will earn interest every year. So the payment interval is quarterly and the interest period will be annual. That's called the general annuity. So we have again simple annuity, same payment interval with the interest period. General annuity different. No. So on this discussion, in our general mathematics, we will be focusing on simple and general annuities. So you can look for other types of annuities on other uh, on on my next videos on my YouTube channel. Yung deferred annuity, ordinary annuity, tsaka yan. So I'll have that discussion. So for now, we will be having the simple and general annuity as part of your learning competency. Our objective for this discussion will be to determine the terms that are related to simple and general annuity, and then illustrate and distinguish simple and general annuities. So you have to learn how to illustrate them and to differentiate them. And number 3 is to represent annuities to real life situations. Of course, to answer problems regarding annuities. No. So let's have now let's ask recall. So when you say annuity, it refers to sequence of payments, equal payments made at equal periods of time. When you say simple annuity, the payment interval is the same as the interest period. If you make payments every month, the interest will also be monthly. General annuity, different. So the payment interval is different from interest period. Say you're gonna make payments every quarter, and then the interest of your money will generate every annually or every year. So that's general annuity. Let us have first the different terminologies that you are repeatedly hearing from me earlier. So we have here the periodic payment. In an annuity, no, in an event of an annuity, so you're going to have the beginning and the end of your payment. No? So we are on focusing on annuity certain. So on that specific duration of time, you're going to make payments. That's called the periodic payment R. And when we say payment interval, no, that is um the time between the successive payments. Let's say for example, you're going to make periodic payments monthly, uh, quarterly. So that's called payment interval. The time between successive payments. When you say term of the annuity, that's now the duration, no, of how long the annuity will last. That's called the term. It's usually in time t. That's in year most of the time. The sum of the future values of all the payments made during the entire term of the annuity is the future value, no, or the amount of the annuity F. So if we're going to solve the value of of R1 or of the first payment, periodic payment, if we're going to compute its value towards the end of the annuity, that's called the future value. No, so we are just going to add the sum of all the future value of this payment periodic payments, and then we will be able to find the future value. On the other hand, if we're going to compute for the present value, let's say this fourth payment that you had, if you're going to compute for the present value of that money today, uh, so you have to compute for the present value P. Okay? That's the present values of all payments to be made during the entire term. So you see that there is um direction of computation. So if it's towards the end, if you're going to compute for the money from the time you paid for it till the end, so we are computing for the future value of your money. So if you want to get the money today, but if it's available in some future time, so you're going to compute for the present value. So let's now have an example of simple annuity. Let's say 50,000 pesos deposited every year for 5 years at 8% per year compounded annually. So per year compounded annually. So it's redundant na, no? So it should be clear now. So this is a simple annuity because you are making payments or deposits every year. And yet, your money will earn an 8% interest annually. So it's clear that this one is a simple annuity. So if you observe, no, from the period, no, so you have the first payment, second payment, third payment, fourth payment, fifth payment. Since this is yearly, annual naman siya, so first year, first payment, second year, second payment, third year, third payment. So you have to make payments of equal values of or equal to 50,000 each of those year. So now, if you're going to compute for the future value of the amount you paid, let's say your first payment of 50,000, if you're going to compute for that, we know that in the 5-year period, your money will be there for 4 years, uh, logically speaking. So we have to compute for that value. So remember that 1.08 came from 1 plus the rate of interest. This is just an insertion of computation for interest. So, on the other hand, your second payment will have 3 years period inside that bank. Let's say you have deposited it in the bank. So, if we're going to compute for the future values of the money you had deposited, you just have to simply compute it manually and then add them all. So your future value will be 293,330.05. No. So this is the cash flow. This is how the cash flow look like with the annuities. Let's have another one. Find the amount of annuity of 700 pesos every 6 months for 12 years if the interest is compounded monthly. So you see that um, you are making payments of 700 pesos every 6 months. So this is synonymous to semi-annual or half a year. And yet your money is earning an interest every month. So it's clear that the payment semi-annually and the interest period, which is monthly, is not the same. Therefore, this is called general annuity. So, unlike the first one, so this is the payment will happen twice a year. Therefore, if you have 12 years and you have to make payments twice a year, that's for the 6th month and the 12th month. So you have 24 total payments of 700 pesos. So if we're going to compute for the future value, so the first payment will have 23 uh, total payment intervals no for the span of 12 years. So if we're going to compute for the value of each of those values of each of those monthly payments, so you'll gain 24,212 pesos and 83 centavos. We just simply add all those values. That's what you call general analysis. So this is how the cash flow look like. But then I will not be letting you compute for those values for the future and present values manually. So we will be having sets of formulas for those problems. So let's start first with simple annuity. So what are the formulas used to find the future value and the present values of simple annuity? So we have it here. Let's just familiarize ourselves with the variables. So we have here the P, that's called the present value of the annuity, and then the R, which is the periodic payment, the amount of money you made, the amount of money that you had for the payment, and then the I will be the interest rate per period. The same in computing for simple for interest, no, the interest will be interest rate per period. So you have to divide the rate to M, which is the number of conversion period in a year. If it's monthly, you divide it by 12. If it's semi-annually, you divide it to 2. So this is clear already to you. And N is a total number of conversion period. If it happens na hindi siya yearly or annually, you have to multiply the number of years, T, and then the number of conversion period in a year, just like what we had in our previous example. That's 12 years of semi-annual. So you have a total of 24 number of conversion periods. So you just have to simply multiply them. Kasi the number of times you make payments in a year also affect the number of compounding interest. So you have to do this one. So let's move on. Let's have some example. So Mr. Angeles paid 200,000 pesos as a down payment for a car. The remaining amount is to be settled by paying 16,200 pesos by the end of each month for 5 years. If interest is 10.5% compounded monthly, what is the cash price of his car? So he's making a payment every month and it's earning interest every month. So this is simple interest. So we are going to a simple annuity rather. So we'll be using present value formula for this. So in our word problem, our R or the periodic payment will be 16,200 pesos. That's 16,200 pesos. And then our I will be equal to rate over M. Our rate is 0.105, that's 10.5%, divide by monthly, that's 12. What is this in decimal? Uh-huh. 0.105 divide 12, that's 0.00875. 0.009. 0.00875. So, pwede naman natin gawin na ilagay natin yung buong yan doon para mas makuha natin yung ano no, yung value. And then our n will be equal to how many years? That's TM. Our T is equal to 5 years, and that's every month. So you have a total of 60 payments. No. So if we're going to substitute that to the formula, we will have 16,200 as our R. And then 1 minus 1 plus our I, which is 0.105 divided by 12 raised to negative 60 all over 105 over 12. So all we have to do is to input that in our formula. So 16,200, and then we have 1 minus parenthesis again minus 1 plus another parenthesis 0.105 divide 12. Let's have the closing parenthesis for this one, another close for negative 60. Let's have the exponent negative 60. And then we have to close this one. And then I think we have to add another parenthesis over here. So we can divide. So we can divide the 0.105 divide 12. So the reason why I did not use the 0.000875 is to let you see how to input all the values in the calculator. I don't usually make rounding off of the values kasi ano siya nagbabago yung value niya. Since we are talking about money here, it should be exact, supposedly. So, the total value that we have is 753,702.20. So, that is 753,702.20. So, this is just the amount or the present value of the remaining amount. But because the question is about what is the cash price of his car, so you have to add the 200,000 peso down payment to identify the total amount of the car. So we also have to follow din naman if we answer the question correctly. So our final answer will be 953,702.20. There you have it. Let's have another example. So, Mr. Edgar borrowed from his friend 200,000 pesos. He promised to pay 80,422 pesos and 96 centavos each year for 3 years. So how much is the future value of the money he borrowed if they agreed on an interest of 10% compounded annually? So the payment is each year and then the interest will be annual. So this is the question is, what is the future value? So future value of simple annuity. So we will be using this formula. So the payment R will be 80,422.96 every year. And then our I is equal to 3 years every year. So that's only 3 now. And then our N is 3 years every year, still 3. So we just have to substitute the formula to the formula 0.96. 1 plus our interest. Sorry, our interest is 10%. 0.10. So 0.10 raised to n 3 minus 1 all over 0.10. So, input lang natin yan sa formula sa ating calculator. So that's 80,422.96 parenthesis 1.1. No, pwede natin siyang ilagay na ganun. Raised to 3. And then, di-divide natin, ma-minus pa natin yung 1 dyan. Minus 1. We need an extra parenthesis over here to group these values. Divide. Minus n, sorry. Minus n. Minus 1. Meron na pala. So, divide na natin yan sa ating 0.10 or 0.1. And then close parenthesis. So the value will be 266,000. When you round off, that's 200. 266,200. So that's the total future value of the payments of 80,422.96 pesos each year for 3 years with an compounding interest of 10% annually. It's 266,200 pesos. Okay, so we're done with the future value and present value of simple annuity. And of course, to familiarize with the general annuity, here are the formulas. So remember, general annuity, different yung payment interval sa ating compounding period. Therefore, we will have an additional variable in our formula. And that is which our B. Where B is equal to P over C. When we say P, this is the number of months in a payment interval. So how many months do we have in a payment interval? So monthly, that's 1 month. Quarterly, 3 months yun, no? How many months do you have in a quarter? That's 3 months. Semi-annually, we have 6 months. Annually, we have 12 months. That's what we mean by P. When you say C, the number of months in a compounding period. So same thing, if it's semi-annually, 6 months yun. Kung ang compounding period ay annually, that's 12 months. So yun yung additional natin na variable for our future and present value of general annuities. Jeffrey has just purchased a new car for $24,400. He borrows the money and will repay it in monthly installments over 5 years. The interest rate is 8.4% per annum. Compounded semi-annually. Find the monthly payment. So, it's clear na ang pinapahanap sa atin dito. No? So, nag-purchase siya ng 24,400, no? Yun yung present value nung kanyang car. So, ngayon, ang gagawin natin, hahanapin natin yung monthly payment R. That's our R. So, we will just divide this equation to this one inside the bracket. So, we will now have R equals to P. Ganun lang naman yung ating substitution dito. Over yung nasa loob ng ating formula. is to be minus 1. So, ganun lang naman yung gagawin natin. Our the present value of this car is, kasi yung pagkakabili niya ngayon. So, present value yun. Our P is $24,400. And then, our I is equal to 0.084 annual, no? Semi-annually. Compounded semi-annually. So, this is over 2. And then, our N, actually, dali lang naman to. Hindi na kailangan i-round off, no? So, pwede natin siyang gamitin as decimal itself. Our N is equal to, how many years is that? That's 5 years. Semi-annual, that's 2. So, we will have it 10. And then, our B, okay? How many months will the payment be? He borrows the money and will repay it in monthly installment. Our P over C, remember? So our P is 1 and the C will be the compounding interest, number of months in the compounding interest. That's semi-annual, so that's 6 months. So this will be our B. So when we substitute that to our formula, no, R is equal to our P is 24,400 all over 1 minus 1.042, we can easily add it already, raised to negative 10 all over 1.42 raised to 1/6 minus 1. So, kailangan natin gumamit ulit ng calculator. So, we have 24,400 divided by, madami tayo ima-minus dito. So, divide by, you just have to be careful in having the parentheses. Kailangan lang natin masaulo yung mga groupings niya. So, 1 minus 1.042 raised to negative 10. So, this is our numerator. So, pag kinlose natin to, when we close that, we have to have this one closed as well. And then, divide by 1.042 raised to 1/6 siya. So, ito kailangan ulit natin siyang i-group. Minus 1. Kasi may minus 1 pa tayo. So, the answer will be 497.75. $75. That will be the monthly payment. No? For how many years? That's 5 years. So, yeah. I hope you get this one clearly. And, of course, if we have present value, we have the future value. So, the payments of $500 are made at the end of each year. So, for 10 years. Interest has a nominal rate of 8%, convertible quarterly. So, the payment is yearly. The interest rate will be quarterly. So, this is general annuity. What is the accumulated value of these payments at the end of 10 years? So, kailangan natin dyan ulit alamin ay this is surely future value. Kasi accumulated value of these payments at the end of 10 years. So, that's in the near future. So, that's future value. So, our R here will be the payments. Payments of, very clear, $500. And then, our I will be 0.08 every quarter. So, divide by 4. Dali ito. 0.02 lang. No? And then, our N will be 10 years times 4. Kasi convertible quarterly. That's 40. 40 conversion period siya. And then our B is equal to the payment made at the end of each year, that's 12 months kung each year. And our C will be the convertible quarterly, that's 3 months. So this will be equal to 4. No. So to find the future value, substitute lang natin yan. That's $500 times 1. Pwede natin i-add yung 0 to agad dito. Raised to n, that's 40 minus 1. All over 1.02 raised to our b, which is 4 minus 1. So madali na lang siya pagka madaling ma-divide, no? So let's compute for this one. That's 500 times 1.02 raised to 40, 02 raised to 40, and then minus 1. So we have to group this one because this will be our numerator, and then divide by the denominator 1.02 raised to 4. And then group natin yan to make it to be sure, minus 1. And so we'll have 7,327.48. That will be the future value of 500 pesos payment. Yan. So that is 7,327.48. 7,000. Okay. So the 500 pesos made at the end of each year for 10 years, supposedly, this is just 5,000. Pero dahil nag-accumulate siya ng 8%, convertible every quarter, yung 5,000 mo na na total amount, it will turn to 7,307.48. So that's the end of our discussion for simple and general annuity. So I hope you get to learn something, the difference between simple and general annuity, how to distinguish the two, the formulas, and the variable in the formulas, how to be able to get that in a word problem. And of course, understanding how annuity works with payments, loans, deposits, and investments. So that's all for week 3 of general mathematics discussion, quarter 2. Bye!